All right, so after you've had a chance to create a method and find your own estimate of the wood in this tree trunk, let's talk about an approach we could have used. So we can see that in this image that this tree acts like a bunch of cylinders. So how could we imagine those cylinders? Well, if we start from the top, we have a cylinder here. And then as we go down, we have some more cylinders, but notice in this first section, our cylinder is not exactly straight, doesn't exactly have straight sides. So how might we think about this shape as a cylinder? Well, something we can do is create an estimate for what that cylinder would look like. So I'll use green here. So at the top, it's 8 feet. At the bottom, we have a 9 feet diameter in this case. So what we can do is find an average diameter. An average diameter between these two measurements. So an average between 8 and 9, 8 plus 9 over 2, would give us 8.5 feet. So we could draw in these cylinders. So first we have a diameter of 8, then we have a diameter of, I'll label here D is equal to 8.5. Next, average diameter between 9 and 10 would be 9.5. So diameter here is 9.5 feet. And then continue average diameter between 10 and 12 is going to be 11 feet. Then average diameter between 12 and 14 would be 13 feet. So now we have diameters for these cylinders. And as we were told in the problem, these measurements were taken every 60 feet. So then the height of each cylinder would be 60 feet. Okay, 60, 60. So then to compute the volumes, we would just compute the volume of each cylinder. So we're going to go ahead and do that. So volume. And we can just right now do volume of all cylinders. We can just compute that as a large sum. So the first one would look like 60 height times radius is going to be half that diameter. So keep in mind, D over 2 is equal to radius. So that would look like 60 times 8 over 2 squared times pi. The next cylinder would be 60 times 8.5 over 2 squared times pi plus 60. So we're now on, keep track of which cylinder we're on. We're on that third cylinder. So we have 60 times 9.5 over 2 squared times pi plus 60 times 11 over 2 squared times pi plus 60 times 13 over 2 squared times pi. So now we can add up all of these terms, and notice we can simplify here too. Each of these terms in our sum has a 60. We can factor that 60 out of each. And each of these terms has a pi. So we can factor out a pi from each term. So what does this become? Well, we have 60 pi times, now we're just going to sum the radii squared. So 8 over 2 squared plus 8.5 over 2 squared plus 9.5 over 2 squared plus 11 over 2 squared plus 13 over 2 squared. And this is a volume measure because we're multiplying 3 dimensions, height, and then squaring the radius. So this would be measured in feet cubed. And if we put this all in our calculator, we get something like 2,400, or rather 24,339 feet cubed. So here is an estimate for the amount of wood in that trunk. You might have gotten a different answer using a different method, and that is completely okay. One thing about this method that we just did that I want to point out is what it boils down, or is the comment I want to make is, what is the process that we're doing? What does it boil down to? What's our summary? Well, what we're doing is we're finding a sum of volumes in various chunks of the tree. And what we can do is recognize some patterns in those volumes and then see some patterns in what we're adding up in order to compute that volume. All right, great work getting started on section 6.2 in this preliminary example.